We are live.
All right. Let's just wait for a few minutes. We've got about 80 people right now. And I think all of us have to tweet once though. Hey, I can always see the comments coming in, but let me also just tweet.
First live streaming of Nischal tweeting.
No, I've done this before as well.
Okay.
All right. Should we start? Omar, are you ready?
Sure.
Yeah, seeing a lot of comments coming in. Hey, everyone. Welcome to the first ever demonstration of the Shardeum Alphanet. There's a lot of stuff to unpack out here. What we are going to do, just to set the agenda for everyone, we'll first demonstrate running about 100 nodes. Is that right, Omar? We'll run a 100 node network first.
Right, exactly.
And then we'll take about 30-35 minutes where we'll run everyone through a presentation, and we'll also have a Q&A if you have any questions about the demo or anything that you see in the presentation. And then the tech team comes back, and what do they do, Omar?
So then we demonstrate a 200 node network. And so what you're going to see is that with the 100 node network, I think the TPS that we will be able to get out of that is about 40 transactions per second. And then once we increase the size of the network to 200, then we'll be able to show the TPS has gone up to 80 transactions per second. And so this is actually a sharded network. And I think this is also going to be the first time anybody has ever demonstrated EIP 2930 transactions being implemented and run in a network.
I'll get to probably later in the presentation. I'll get to asking you what exactly is EIP 2930.
Sure.
I'm guessing everyone would love to hear that as well. So, and you're seeing that the TPS, as you add more nodes, the TPS increases. Is this something that's been a norm in the blockchain world, or because I've been talking about this being innovative, but in terms of I would say linear scaling, what we always hear about when we talk about Shardeum. Can you shed some light, a brief description, so that everyone understands, because that's what we'll be demoing today, right?
Mm-hmm. Yeah, definitely. So this is definitely not the norm in smart contract platforms. Most of them are taking the approach of basically just vertical scaling, which means that if they run into problems with not being able to handle more transactions as the usage picks up, the only alternative they have is to try to increase the hardware, and you can only do so much with that. Very few projects have even considered horizontal scaling, and so Shardeum is implementing this, I think, for the first time in a way where every node that gets added to the network directly increases the TPS. There's other projects out there like Near and Harmony and Silica, which are also implementing sharding, but they do it with the more static nodes per shard approach, right? So with that,
so what happens is when a new shard comes into the network, only then the TPS increases, right?
Right, exactly.
While out here, this sounds a lot like how Web 2 operates to me. with in terms of scaling, which is a great thing. We don't want the centralization of Web 2, but I think we definitely want the whole speed and the scaling of Web 2, which is coming into this. That's amazing. So let's do this. I think what we can do is, because we'll have a lot of time to talk in between the two demo. So how about we bring in, I think Andrew and Amir to demonstrate the first part of the demo, and then we'll get back because I have so many questions and we also have to share the presentation. So yeah, can we have Andrew and Amir out here?
Hi guys, let me get my screen shared. Oops. All right, is that coming through okay?
Yeah.
Yep.
All right, so what we have here is our 100 node network. And we had these nodes join in before the meeting here, the demonstration, and we've got 100 active nodes. And this is kind of our display of the network, and it has debugging stuff for the team as well. And what I can start out with, we're going to do some load testing on it, but what I can start with is I have a MetaMask set up and a test account. And this test account hasn't done anything with the network, and it has 0 SHM. So for Alpha, we have a faucet so that for debugging, people can get some coins on the network and start testing and developing and trying out their contracts. And so this is our faucet page. I'm going to paste in my address there and request the SHM. And it says I'll receive it soon. It takes kind of a variable amount of time for MetaMask to pick up on that. Sometimes it's instant, sometimes a couple seconds, but we'll see this jump to a minute. And there we go. So now I have 100 SHM claimed on the network. And if I tab over to Remix, I've got Remix set here. We have this little smart contract. It's a ERC20 token. Like most of the source code is getting included. So we just set the sort of the name and the token symbol. I'm going to compile it. And, this Remix is a standard tool. It's really great. And I have that same account there, my test account, and it says 100 Ether, but it's 100 SHM because I have it pointed at the Shardeum test network. And so I can spend some of that to deploy this contract I just compiled. So I'm going to put the initial supply in and hit the deploy transaction. Close that one from before. I'm going to get asked by MetaMask, just like you'd expect, about deploying it. So I'll hit confirm. Any like gas fees you'd see in that are just kind of still like debug and not, eventual gas fees. So that'll go through the network and should deploy in a minute.
So Andrew, while we wait, it
Yeah.
looks like Shardeum is EVM compatible, obviously, correct? And smart
Correct,
contracts are written in Solidity or Viper.
Yeah, I guess anything that compiles to run an EVM bytecode. I'm sure there's way more of them out there than I know about, but it's a nice thing about using the EVM.
Awesome. Yeah, I think that means, during the Alphanet, we're very excited to invite developers who have existing Ethereum EVM-based applications to port to the Shardeum testnet, and also invite the community to begin deploying smart contracts on Alphanet and building their own apps on Shardeum in preparation for mainnet. Really great opportunity now to begin building your ecosystem within the Shardeum community.
Mm-hmm. Yeah, we demoed this deploy on the last demo as well, and it's kind of going a bit slow on me right now, acting up like a demo. But rather than get hung up on that, I'm going to go ahead and start some of the load testing, and we'll see later if that comes through. So for this load testing, we're starting a number of clients, and what they're going to do is they'll each spend some time creating up a pool of smart contracts. So in this first test, we're going to create 120 smart contracts and about 600 end user accounts. And so once the smart contracts are deployed, the clients are going to be generating a large amount of smart contract traffic. So they're basically all are going to be sending each other like randomly different tokens, because there'll be like 120 tokens deployed.
Hey, Andrew, do you have the charts open on a tab?
Yeah. Oh, good point. Good point. Let me get that chart open. All right. It'll take a little. This chart will probably populate once. Takes a minute, but then it'll start to get our demo performance. So I'm going to start the process of deploying the contracts here.
So just to kind of give you an idea, so these are nodes running on AWS. They're T3 medium type nodes. So there's 100 of them. I think they're currently all in one data center right now. But that's just because for some of the work that we were doing previously, we just needed them to be in one data center. But we've done these tests before with the nodes deployed in like 20 different data centers. And then also like the green dots that you see, each dot represents a node. And then within each node, you're going to see like 3 smaller dots. And those dots are basically representing like an internal state within the node. And so we just color code the hash of the state, right? So we use that as a RGB color. And so if all of them have the same color, then that means, things are synchronized. But it's a really easy way to tell, like if a node goes out of sync, it would have, an internal dot, which is of a different color. And then you'll see like little red dots going across the screen once in a while. And so those represent actual transactions that are being sent to the network. So Andrew, did you start some transactions there? Because I just saw some red dots.
Yeah, these are started now. And so right now, just because of the way our load testers are set up, they kind of take their time deploying the 120 contracts, and then they'll sort of stop sending for a minute, and then all at once they will just start doing a large amount of smart contract token transfers.
Yeah, and so the transactions that you're going to see this network get hit with, they're actual, real ERC20 type token transfer transactions. So they're not like coin transfer transactions, which are usually like lighter weight. These are actually hitting smart contracts, and it's requiring the EVM to get invoked and execute those. smart contracts. And we have like various metrics in the top right corner of the screen there. It's basically showing the number of active nodes. Then there's also the total transactions processed. So you'll see that number steadily increase as more and more transactions are sent to the network. And then in the row below that, there's also it's tracking the average transactions per second that the network is seeing. And then there's also rejected transactions where, like, if the network is getting overloaded with too many transactions, our approach is basically for the server to tell the client that, hey, try your transaction again later. And so we refer to those as rejected transactions.
And that's a really good, and that's a very good feature to have, because the network accepts like the healthy amount of transactions. So okay, now they're just getting, now the load test is really ramping up now.
Yeah, so now
and actually with this test, I'm putting out like more load than we know this 100 node network will be handling. So it's actually going to process as many as it can, and then reject, like, kind of statistically anything that's over capacity. And that's fine though, because it's a way of seeing what the network can handle at its maximum. And that's how we can know that linear scaling is happening, because we'll double the size of the network later and hit it with another load. If I go to the charts here, this was the phase when we were sort of deploying the transactions, and now that the main load is going, deploying the contracts. And then right now what we're seeing is this blue line is the transactions per second of the smart contract calls. And the sort of yellow line down here is when it's rejecting the extras, because I'm hitting the network with more than it would want. And that's one of the things we've been testing the alpha, a lot in the last 2 weeks is, we want to throw too much at it and make sure it stays stable and happy. And then of course, like in the real world and mainnet, besides that, it might reject some when it's at its limit, it's also going to send messages that allows the network to grow inside us as well. And so that's when, if there's people that are, waiting, they have validator nodes in the waiting list, and that extra load is detected, it'll be accepting more nodes in. Nodes will always be getting accepted in as we rotate them through the system, because your node will be a validator for a while and rotate out. But if the load goes up, then like the amount of nodes getting accepted is going to be more, and the network will grow, and then it'll handle higher loads. So yeah, this is still going. And
hey, Andrew, sorry to interrupt you as well, but the Zoom video tab is hiding the chart in the top right. So I don't know if you want to move your browser, or if there's any way just to allow the community to see that chart.
Yeah, okay, interesting. I moved the tabs myself. Can people, hey Greg, if you move your Zoom video tab, or is that a local thing?
I think it might be coming from Chandrash's, but I was just going to say you can move your browser, but we don't need to.
Let me just do that. This isn't the most like rescalable display, but we'll just do this for a moment. So here you can see the different displays, max TPS, average TPS, rejected, and then there's some like developer stuff, but and then it's total processed.
Can you just explain the numbers on the screen, so the number of nodes, etc.? If you could just go through that.
Yeah. So we have 100 active nodes, and there are a total of 100. Desired for this demo, we just set to some really high number. in like the real world, the desired would be based off the load. So that when I was talking about the network being busy, it would say, oh, it's really busy right now. So now we want to have more nodes, and that's going to adapt over time so that it has the right number of nodes for the network, right number of active nodes. And our total processed is just total process transactions. Our network has this concept of cycles. I probably won't go into all the details there, but it's basically a method that is accounting for who is in the network or not in the network, and some various other like network maintenance and roles. And we're changing cycles about every 60 seconds here. So we have max TPS and average TPS, and rejected transactions are the ones we threw out when there was too much load. And then these settings down here, they're a little more sort of dev oriented, but they're kind of based off of the network sees a load of 0.719, which means it's going to want to scale up if we were allowing it to scale up right now. But we will, like, in just a minute here when we're kind of wrapping up this part of the demo, we will launch 100 more nodes on AWS, and they will sync into the network.
Yeah. So Andrew, what just happened is we had a few load clients that were hitting the network with the token transfers, heavy smart contract transfers. And the 100 nodes were processing average of 40 transactions per second. And so, with the roadmap of what Shardeum is building, we're about to, manually add 100 more nodes. But what is the goal of Shardeum on its future roadmap when the network approaches its capacity in an instance such as?
Yeah, so like in mainnet, that's just going to be based on the natural growth of the project. So as more people are excited and have validators joining, they'll be in the standby list, and the network will grow its active number of consensus nodes based on the load. So we want to see that number get really high because it's a compelling platform with just super low fees, and it's able to just keep scaling and scaling because we have this linear scaling for horizontal scaling. And so, we want to see really big numbers there.
And with this test, I think it's important to note that these transactions, this is in a sharded network. So, the source and destination of the transfer could have been accounts in completely different shards. And, the network just, handled it. In fact, so in terms of like the number of shards that we have in this network right now, I think, we have a redundancy of 11, Andrew, is that right?
This has a redundancy of 11, but because of the like sharding tech level that's kind of inactive right now, these smart contracts are using probably a redundancy of 33 for the sake of handling the multiple accounts in a smart contract call.
Yeah, so basically it's like a redundancy of 33. And so, we have the 100 nodes divided by 33, and any one node by itself could get like 15 transactions per second. And so now we have 100 nodes times 15 transactions per second, and then divided by 33, and that's where we get a number close to like 40-ish transactions per second.
That's correct. And in the animation, when you would see a red dot come in, that represented the injection of the transaction, but it may not even have anything to do with the node it was injected on. There's a routing process that it actually spreads it to the 33 nodes that would be involved in the transaction. They would do the work.
And also important to mention that this is the first time I think anybody's demonstrated transactions that are EIP 2930 compatible. And basically EIP 2930 is a standard that was proposed when Ethereum started thinking about doing sharding. What that standard says is that a transaction can optionally include a list of addresses that will be accessed when that transaction is executed. And knowing that ahead of time allows the transaction to be routed properly. And so we're taking advantage of that and we've actually implemented that capability.
Awesome. Andrew, so the next step would be where you will now spin up 100 more nodes, right?
That's correct. Yeah, I just told AWS to launch 100 more nodes, and
okay, so we are all waiting now.
Do you want to
Yeah.
So excited.
show a quick, Andrew, do you want to just kind of show a quick thing of what that looks like when these nodes are getting launched?
Sure. Let me give me a second here to.
So you have visuals for that?
Yeah. So we'll be able to show you those nodes that are,
Yep.
in the standby, and then as they join, maybe we should kind of just show a few nodes starting to sync.
Sure. Yeah, and
How long is it going to take for the nodes to start showing up?
we're probably about 2 minutes out before the the nodes they've got to
Right.
spin up and
Mhm.
initialize, start the
Got it.
Docker and whatnot, but
Okay.
they
so
come
maybe-
in about 2-3 minutes here.
Okay.
Great.
So I think maybe we
So
could-
one of the
Yeah.
I think in the meantime, what we could do is we could in fact answer a few questions that I'm seeing, which probably will help everyone better understand the demo. I think one of the question is because we just showed 40 TPS, people are worried, is it only 40 TPS? And I think this is what you're going to see next. I want everyone to know that 40 TPS is with the 100 nodes. And again, there's a lot more optimizations to get more TPS out of those 100 nodes. But the idea is now if 100 nodes, if let's say you have a worst case scenario, which is 100 nodes giving you 40 TPS, what happens when you add 100 more nodes? So that's where we'll be going next. Omar, you want to add something to what I just said?
Yeah, absolutely. So basically, if we're doing like 40 TPS with the 100 nodes, then if you scale that up to 1,000 nodes, that means we'd be able to do 400 TPS. And just to kind of put things into perspective, if you take the TPS of like Binance Smart Chain, Ethereum, Polygon, all on their most active day, on their peak days, all of that doesn't even total up to 350 TPS, right? So, just to kind of give you a perspective of, what 400 TPS kind of looks like. So yeah, definitely. And we want to go way beyond that too, right? So if we go to 10,000 nodes, then, we're looking at like 4,000 TPS. And so, yeah, it's just gonna keep going up.
So let's do this. I think there are quite a few other questions, but I think if we can quickly run through the presentation, I think a lot of these queries will get solved from the presentation, and then we can take more questions. Andrew, can you share the presentation, or Greg, anyone? Yeah.
Greg,
can you go to the next slide? Yeah. So yeah, I think one of the things, and this is more or less, we've been sharing all of these information, but we're just going to go through them again. And I saw a lot of questions around the high gas fees. While we haven't really set the fee yet, the idea is that because there's linear scaling, the fees is going to be a constant, and it'll always be at a minimum that we set. And when you need more TPS, all that you need to do is get more nodes to join the network. As against preventing you from getting your transactions executed by making the fee high, the idea is to attract more nodes to join the network so that you can continue to run your transactions at the same low fee that we initially set. And I think this finality, I think I would let Omar, talk a bit about this. And I think, Omar, there were questions around this as well. Someone said, wish there was quick finality. So can you just quickly tell about how transactions get finalized on Shardeum?
Yeah. So, I mean, essentially there is, immediate finality in the sense that we don't have probabilistic finality, right? So once a transaction is committed, there's no rollback possible on that transaction. So it's immediate finality. Now, what's the turnaround time, which is also referred to as latency, that can vary, right? In terms of, how long does it, take for MetaMask to poll and queue and recognize that a transaction has gone through. Also, there's some queues that Shardeum implements just to make sure that, transaction ordering is done properly. Just ordering the transaction as they come in takes a little bit of time. So it's not that, like the latency and the turnaround time is not going to be like instant, but it'll be a few seconds, right? So
and do you think it'll be a few seconds even in production? And would this latency and time, would that also, let's say, exponentially increase with the increase in the number of nodes in the network? Or can you tell a bit about that?
No, it should be a constant, right? So the latency will be a constant. It won't increase as you increase the number of nodes in the network. But these are latencies that are going to be there. Just because a transaction needs to get propagated and so forth. Now, one of the nice things is that in a sharded network, the transaction doesn't need to get propagated to every node in the network, and so there's actually a constant latency due to the network, as opposed to like other networks where the transaction
they have to sync everywhere.
Yeah, has to get to every node. So.
Got it. So the next is, again, I think this is one more where people are asking, will there be a barrier to entry for running a node? I think right from the beginning, when we've been thinking about nodes that you can run, our objective has been to ensure that maximum people can join in and run their nodes. And that also leads to greater decentralization. So while we haven't zeroed in on the exact specs of what the node, the machine specs for the node, but I think it's going to be something which is going to be affordable, and most of us will be able to run it. In fact, I think Omar was just saying it. What are you running this on currently right now?
So these are running on T3 mediums, and so we figure like you could spend about $50 a month for renting like a dedicated server, and that would probably be sufficient for running a Shardeum node. I think the bigger hurdle might be, having enough SHM to stake or something like that, because that kind of, I mean, there's a trade-off, right? Because with security, right? Because we want to make sure that the nodes that are participating are honest nodes. And so you're going to have to stake something to show that you're running an honest node. And that, hey, if my node misbehaves, I'm taking a risk of my node losing some of the, amount that it's staked, right? Because there's no way to prevent somebody from running like a really subpar node, right? Like you could run like a $10 VPS server and try to run it and run this, and you could try to participate, but your node wouldn't be able to keep up. And so in that scenario, your node is going to get kicked out of the network and probably get slashed. And so that disincentivizes people from, trying to run with nodes that don't have the proper hardware, right? So yeah, so the hardware is pretty affordable, but also as the total lock value on the network increases, then there will be an increase in what needs to be staked to have a node.
And I think we are still working on the staking, the minimum staking amount required. And all of you listening, please join the Discord channel. because everything is being discussed with the community. We are taking all of the feedback to come to these numbers. The next is the third point out here, which is auto scaling and scaling linearly. I think this is what the next demo will show you. You've seen 40 TPS, 44 TPS at 100 nodes. What you're going to see now is what happens when you add 100 more nodes. So we are demoing this. The fourth is my personal favorite. If you saw the demo today, Andrew just used MetaMask, and there was no need for us to create a new wallet and learn a new language and do all of that. We could just tap into MetaMask, which is an existing wallet built for EVM, and this was one of the biggest motivators for us not to divide the entire developer ecosystem who are building on blockchains, not to create more trouble for developers. I think all of us with tech backgrounds, we understand what it is to maintain multiple code bases for the same product. So I think this was something we consciously decided to go with EVM, and we are glad we did, because once Shardeum launches, you could just use all of your favorite apps to start using Shardeum as well. You can just use them on Shardeum. The last point is, if you've been part of our Discord channel, you realize how we operate as a team. All of us, there are no secrets. The community knows everything. In fact, our root folder on Google Drive is open for everyone, and we intend to build it this way because this is a true open source project. It's not my project or someone else's project, or it's everyone's project together. We are all playing a part, and we believe that getting the data out in the open is like the best way to show where our focus is, which is to build this with the community rather than build and then let the community understand or think about it. We are getting you on day one, and I think I would encourage all of you to join the Discord channel. There's a lot happening. There's so much of fun stuff, and there's so much to learn. A lot of brainstorming. It's amazing. So please join the Discord channel. Can we go to the next?
Yep, Omar,
Yeah.
Could you just real quick touch upon auto scaling and the difference between what we're doing today versus the roadmap of auto scaling? And a lot of questions about if just adding nodes adds redundancy, but just reiterate the benefit of increasing TPS per node.
Yeah, definitely. I mean, with auto scaling, our network is going to be able to detect the load that it sees and, bring more nodes in from standby to active in order to grow itself and handle, the higher TPS. And we can actually think about even doing this, whereas other platforms can't, because for us, it's very seamless to grow the network, right? Every node that joins the network increases the TPS. And there's no need for developers to be involved to say, oh, we need to create another shard. The team doesn't have to do anything to do that. The network just does it. Whereas, with other platforms where they're statically sharded, they're really like, okay, do we want to add another shard now? And then the developers and team have to get involved. And even the developers have to consciously think about, oh, which shard is my smart contract going to get deployed on? With Shardeum, it's completely seamless, right? You don't have to worry about where it's getting deployed. The network just handles that, and it's completely opaque, and so it just feels to you as if you're using, an unsharded network, but underneath it's sharded and, just handling this, the higher TPS and being able to handle, the higher TPS as the network, gets more popular. That is really what allows us to have sustainably low fees, right? Because every new network will always have low fees when the usage is low. But it gets interesting when the usage starts to pick up. Then what happens, right? So can you grow your capacity, or are the fees going to go up?
Thanks, Omar. So here we're just sharing a few metrics. We launched publicly and spoke about Shardeum on the 2nd of Feb. So it's a little over 2 months, and the metrics are in front of you. This has all been organic. We're close to. I was just hoping that before the demo it reaches 5,000 people on Discord. I think we are about 10-20 away. But yeah, almost 5,000 people on Discord. Twitter almost 9,000. I think these are very close to all those key numbers. Telegram channel has about 3,700 viewers there. We have around 13,000 visitors on our website, 2,000 plus newsletter subscribers. YouTube is probably the slowest because we've had only one YouTube session. This is the second one. And we'll try to be more, I would say, more regular on YouTube as well. Now that we have the Alphanet demo, now we'll have a lot more updates, and we'll try to present them out here. But yeah, I think we've got a lot of buzz. That initial buzz that you need for a project to start really taking off in terms of the I would say in terms of branding and understanding and everyone talking about it. I think Shardeum's gone from that first ground zero to probably ground 0.1. We need to go to 1, and we need to keep pushing as a community to do that. Let's go to the next one. Yeah, so these are some of the roadmaps. I'll talk about a bit, and Omar, I'll need your help in between to explain some of the objectives out here. The first was we had to build out the foundation. The foundation, we've submitted everything. Now we're just waiting, and I think we're about a week away. Once that is done, we start our private sale, and after that, we can start figuring out how to also involve all of you, because I'm seeing a lot of messages I keep getting all the time, which is how do we get involved in the SHM sale. And believe me, if we could, we would just have one public sale. But regulations, you're all aware how they function. But we're trying to figure out how do we get everyone involved early on. We're now also, Omar published a light paper sometime back. If you haven't read it, please read it. So I think Q1 we did deliver what we promised, including so the Alphanet, which is now in Q2. So Q1 is done. Q2, I think we had a great start. So we have a demo today of Alphanet that you're witnessing. The idea is also to launch and put this out in the public for everyone to access. The security audit will follow after that. Q3, I think Omar, okay, so let's do this. I think Q2 is Alphanet, and I can see BetaNet in Q3. Can you explain the differences? What would be in the Alphanet and what would be in the BetaNet? And one more thing is, if you want, there's in the next slides we have it deeper. Do you want to go there directly? Because I think those are the two major things to be spoken about. Do you want the next slide? We can just go to the next slide.
Yeah, or yeah, definitely.
Yeah,
but I think from a high level, I think the key thing that from the user community, what they'll notice is that in Alphanet, they won't be able to run validators yet, but in BetaNet, that's when they can start running their own validators and joining the network. So that'll be the biggest thing. The other thing is that Alphanet will be kind of starting out small and taking baby steps and building up. And then, with BetaNet, we're kind of up to like medium, but then by the end of BetaNet, we'll get to, like the size that we want for the mainnet launch. So yeah.
Great. So you mean to say in BetaNet, anyone can run their node? You can you can attempt BetaNet, running a node.
You can join, run a node, join the network. Yeah.
Great.
And
I think that'll be fun.
Yeah, definitely. Yeah, so for the Shardeum Alphanet, we have it broken up into like multiple phases, where initially we're going to start with the smaller network, and just these nodes will be all operated by our team right now. But this will give the community a chance to deploy smart contracts to these networks to interact with the network and play around with it and get a feel for it. So in phase 0, it's just a small network of, we're shooting that it's going to be able to support like 10 to 15 TPS. And then phase 1.1, we increased the size of the network a little bit. And then, people can start deploying contracts to it. You want to go to the next slide? Yeah, and then 1.2, then we start focusing on, making it sharded. We already do have sharding in the lab as we're demonstrating it today, but we're gonna make it available to the public, and then that way you can see that, even on a sharded network, what it feels like to actually deploy contracts and interact with that. And then phase 2, that's when we start increasing the size of the network. So we'll be going up to like 120 nodes. And then we also add rotation, where basically with rotation, what happens is that the oldest node in the network will be kicked out, and then a new node will be allowed in. So we'll have like a total of like 120 nodes up there, but only 100 of them will be active and 20 will be in standby. And so, every approximately 1 minute, one of the nodes that was in standby will be added to the network, and one of the older nodes will be kicked out of the network. And so what this allows is that it actually increases your level of decentralization, so that it's not just the active nodes, it's the active nodes plus the standby nodes. So anybody trying to do like a 51% takeover isn't just trying to take over the active nodes, but they have to have a 51% of even the standby nodes as well. And then in phase 2.1, yeah, can you go back just a little bit? Yeah, basically, then we're gonna allow like non-trivial transactions and so forth. But yeah, I won't get into all of those details. Okay, you can go to the next slide. Yeah, and then so once we get to the end of Alphanet, then we're pretty much ready to go to BetaNet, and that's where, like in BetaNet, the community will be able to start operating their own nodes and joining them to the network. And that's also, when we'll be making the code completely open source. And, during BetaNet, our goal is to increase the size of the network and grow it to, 1,280 nodes. And that's the size of the network we want for our mainnet.
So in the BetaNet, we'll need help from everyone to put those nodes and reach that number. It'll be fun. I think we should have an event, a day when everyone runs a node, so that we can hit this number. It'll be fun, I think.
Yeah, absolutely. And there can actually be even more nodes than that, because we'll want a lot of nodes in standby as well. And so yeah, and basically in terms of the marketing, we're targeting, of course, India. We have a lot of community there that knows Nischal and knows about the project, but also we want to target emerging markets because in the emerging markets, the price sensitivity of the transaction fees is really, really important, right? I mean, the big whales can afford $50 transaction fees, but when the transaction fees get above, like I'd say even a few cents, some things become not feasible anymore, right? And so maintaining really low transaction fees forever is really, really important. And then, of course, the Shardeum Foundation will be set up by then, and we'll be, hiring more developers, and yeah, and
all right, cool.
There's a lot of exciting
Sounds good.
stuff coming up.
Yeah, I think what we can do, I was thinking, is one is we need to get to Q&A. There are so many questions. Um, is this the last slide? Are we done with the presentation? Can you go to the next one? Okay, let this remain. So yeah, I think Omar, before we open up and start asking, like answering questions, I was just thinking, we'll talk about a few things. So the first is the Alphanet that we're launching. Everyone's seen the demo, and we haven't announced the date, but very soon we'll announce when the Alphanet goes live. The question is, what exactly can, let's say if I'm just a user, a non-technical guy, and the Alphanet's not launching. What are the things that I can do with the Alphanet? Can you shed some light on that?
Yeah, definitely. First of all, I want to say, we want to be one of the first projects to deliver things on time.
On time.
Definitely shooting for that. People have gotten so used to seeing, projects in this space just, promise things and then just keep pushing the timeline back. But
and just FYI, I think Omar and the rest of the tech team hasn't slept over the weekend.
Yeah, right. So yeah, we weren't initially gonna show you a sharded network, but then Nischal said, can you make it more exciting?
I heard that. I heard that when you said, and I was surprised, because we were going to demo a non-sharded network, and when I heard sharded, I was like, wow, this is amazing.
So we were working throughout the weekend, even staying up pretty late in the night, and kind of getting things working for this demo. But yeah, so aside from trying to deliver all our roadmap, one of the things that the users can expect once Alphanet is out is that they can look at what it's going to be like to develop on this platform, and hopefully what they'll find is that the experience is very, very similar to deploying on Ethereum. And also what they'll find is that they don't have to think about sharding, that the fact that the network is sharded. They can just write their smart contracts, have composability, not have to worry about which shard their smart contract is landing into. All these things will be just like seamless. And, the experience, hopefully, for somebody that's already a smart contract developer on Ethereum, will be just, very, very smooth.
Amazing. And we'll have a faucet, so anyone who wants to try sending SHM to each other can do that, right? And anyone can create their own tokens as well. They can deploy a ERC20 smart contract and they can have their own tokens. Any developer can, and if you've already built it for EVM, you just have to make a few minor changes and it starts running. I think the other important thing that a lot of people have asked, and which needs clarity, because I think this is a little different, is the type of nodes in Shardeum that'll be there. Because what we're showing right now are the validator nodes. So can you just briefly explain to everyone the type of nodes we have, because that's something that everyone's asking out here.
Yeah. So basically the most important, of course, are the validator nodes, right? Typically, that's all most networks have, are just validator nodes. And of course, that's there in Shardeum as well. But what happens is that as the network continues to accumulate more and more transaction history, that history has to be stored somewhere, right? And so typically what blockchains have done is that the validator nodes hold all of that history, and thus causing these validator nodes to have to have really large disks and so forth. So what we've done with Shardeum is that we're pushing off the transaction history to archive nodes, and that way the validator nodes can be more lightweight, and you don't have to have lots of disk space to be able to run validator node. And so now we have this new concept of archive nodes, and those nodes then hold the whole history. And so if you wanted to like, explore through the history of the transactions and so forth, you would actually be hitting those archive nodes. And the archive nodes don't participate in any consensus. So, all they're holding is provable data that the validator nodes, pass back to them. And so that separation is what allows, Shardeum to be able to synchronize faster as well, because a node that's joining the network doesn't have to pick up all of that historical data and in order to catch up to the network. A node in Shardeum basically is able to catch up to the current state of the network in a matter of minutes. Why? Because the main thing that the validators need to really hold is the current state of the network. And so that just changes the perspective of how you view things and what's possible. The other thing that we have are what we call standby nodes. And standby nodes are basically nodes that are wanting to join the network, but because in Shardeum, the network decides on its own what size it needs to be based on the load and based on our minimum settings of, for decentralization. Then the network, you can't just like throw 100 nodes at the network and get them all into the network, right? I mean, it's a good feature because it prevents civil attacks, and it also, it also helps to maintain decentralization, right? Because we rotate these nodes so that the oldest node that's active will be, removed from the network, and a new node that's in standby will become active. And so that keeps all these nodes rotating and keeps the network from, kind of being taken over even with a long time, long range attack. So, yeah, so those are the three types of nodes.
Thanks, Omar. So basically, the archive node is where the historic data is, all the transaction data. The validators is where your transactions get validated, and the standby are, in a way, they're validated nodes, but waiting to be let in to become the validators. So in a way, if you think about it, the standby really is it's more processing power, which is there. If in times when there is a increase in a spike in the traffic, then I'm guessing this is also going to play an important role, the standby nodes, in helping the network, increase the TPS faster compared to if there were no concept of a standby.
Yeah, absolutely. Right. I mean, standby nodes allow, if there's a sudden spike of usage, we can start pulling in more nodes and the network can stay ahead and, continue to maintain low transaction fees, even if there's a sudden, like let's say some CryptoKitties or some, something that gets deployed, which suddenly kicks up the usage on the network. We're not going to see like, transaction fees go through the roof one day, right? So we'll just see the network grow, and then maybe as that, hype wears down, then the network will kind of shrink back down. And so the other thing that the standby nodes do, as I mentioned earlier, is that they help to increase the total decentralization level of the network.
And I'm not sure. I don't think we've discussed this already, but can you explain how a standby gets to become a validator, and what happens to the validator? Do they get back to being a standby? Can they jump back in? Can you just explain this whole rotation and how that operates?
Right. Yeah. So basically, what's happening is that nodes that are in standby periodically will submit a request to the network asking if they can join the network. And there's, some network generated, randomness that is then used to select which of these, like maybe you have, 1,000 nodes in standby, but only, let's say, 5 are going to be added on this next cycle. So the network generated randomness is used to, randomly select, 5 nodes from the ones that are available to join. And then, the nodes that have been in the network for a long time, some of the older ones will be removed. And those nodes then, go basically into the standby mode. So if you just, turned on your validator and left it running, you don't have to think about doing any, involvement between when it goes into, standby or active. Your node will just be running. It might be active for one day, then it goes into standby, then it gets pulled in again, becomes active another day and so forth. So it'll be, going back and forth between being active and standby. And you'll see that over a period of a month or so, maybe it went active about 15 times and it was, in standby, for 15 days, active for 15 days and so forth. And, at the end of the day, you're just going to look at your, how much have I earned, and see that number going up. And, if that number is greater than what you're spending to maintain this node, you might be spending, like, let's say $50 to run this node, but you're getting $500 a month by running this node from the SHM that you earn. That's, what's really going to matter. And yeah.
And while nodes become a validator or a standby, can we get to know for every node in the network how many transactions they process, or can you shed some light on what sort of metrics can you derive out of each of these nodes?
Well, I mean, there's various things that we're tracking within the nodes, especially when we're debugging these. So we have like internal maps of exact number of transactions that they process, what types of transactions, how long the transaction spent in each of the different functions internally. But for end users that are operating nodes, these things may not really be that important. But as we're developing the software, we
But I
look
would
at all
love to
these.
know the transactions my node has processed. I think that is something that a node operator would at least just to be proud about it.
Yeah, I mean, yeah, that's a metric that we can. So we have a dashboard which a node operator would have, where it kind of gives them like a live view into what their node is doing. And so on that, we could display how much time the node has been in the network, how many transactions it's processed, how much time it was in standby, all kinds of different metrics. But yeah, I mean, and user input and community input is definitely welcome on what they'd like to see on that.
Great. So let's take a few questions. I think one of the question is in the BetaNet, how do I where do I get the SHM tokens from? I think we spoke about this. This was there's a test faucet and anyone can get SHM. And I guess we'll keep the minimum staking to a, I don't think it'll be too high for the test net. You can just, so that everyone can run their test nodes on the BetaNet. So yeah, and don't worry about it. These are test tokens, just FYI.
Right,
I think very important.
Basically go to the faucet and you can get your
No, I'm saying these are test tokens. They hold no value. Please, because the question seems to be there. Surprise, how do we offer SHM before we go to the mainnet? So these are purely test tokens. The next question is, does Vitalik know about Shardeum? I don't know, or at least I don't know. And the follow-on question is, what if yes? What was his first reaction? I would love to know that. But I think the best way is just ask Vitalik. He should be able to. If he does not know, at least he'll get to know about Shardeum. He'll be good.
Right. Yeah, I don't think he does know about Shardeum, but of course, he knows that sharding is a very important thing, right? So
yeah. but he'll know soon. I think everyone will know about Shardeum. If everyone from the community starts talking about Shardeum, explaining what sharding is, what we are building at Shardeum, we'll be able to take this to everyone. And I think that's the goal. Someone's asking if Shardeum will have its own stable coin. We haven't really thought about it right now. We are focused on getting the mainnet, and from then I think we'll figure out. We'll have a better understanding. But right now, the core focus is how do we give everyone a linearly scalable sharded, blockchain where the fee remains really low even at high TPS. And I think that itself is an amazing goal to achieve. So yeah, as a team, I think we're going to be focused on that. But never say never. There are so many things to be done. So yeah. But if anyone else is planning to do any of these things, please feel free to reach out to us because I think we would love to help. If you have any ideas you want to build, Discord, like I said, Discord is one of the best places. The entire community exists. We are all active. So discuss your ideas, talk about it. And I think this is the best time to start because you have less competition. You're early. So the initial community is usually in any network is the strongest. So, it's a great time for you if you're a developer to come and get some amazing feedback, make some friends. And, when we launch the mainnet, you can launch with us. We'll definitely push, the products that are built early because they'll not be in thousands. Once too many products are built, it's really hard to, for everyone to push each of them. But right now, if you build, it'll be really easy for us. We can have some specific number of launch partners as well. So I would really, suggest getting into building for Shardeum. And the best thing is you build for Shardeum, you build for so many other, including Ethereum and vice versa. That's the good part about this. Quite a few questions coming in, but yeah, I think, Greg, do you want
I think now's a good time to now's a good time. We talked a lot about we started with a network of 100 nodes showing 40 TPS. We talked about scaling that to 200 nodes showing 80 TPS. Currently the nodes are syncing, so let's take a break from the back and forth Q&A, and we can switch to Andrew's screen just to show the nodes syncing and talk about what's going on here.
Got it. Is that sharing okay with you guys?
Yep, looks great.
All right, so what we have here is the gray nodes are basically standby nodes, and then green nodes are active and yellow nodes are syncing. And
so Andrew, did you accidentally blow away the original network we had?
I did. It was user error. My AWS deploy command queued up the wrong one and it nuked our network. So sorry about that. We are
grow the 200 node network from scratch.
Correct. So it's growing from 0 to 200 right now.
And we're about halfway through. Yeah.
Yeah. So that means a little more extra time for questions today. But yeah, we're at 89 nodes out of 200, and because it's something about growing these networks is that, and there we saw more nodes just become active, and when a node becomes active, it is joined into the network, and then it goes into a syncing phase, and then when it's finished syncing, it will go active.
So the nodes that are yellow are syncing, right?
Correct. And once per cycle is when the network looks at how much load it has had, and it will cycle out old nodes and figure out when we should how many nodes can join the network. And right now we have the desired node set to like 2000. So basically any node that we start will join in right away. In later in tests, probably starting in beta, we'll have a load factor, so it'll actually take the network getting loaded before it'll grow to a certain point. And, you know, in the terms of when you're looking at a network over like a 24-hour time, generally the loads you see kind of grow and shrink throughout the day, depending on what like markets, you know, doing the most transactions. Of course, this will be global, so you know there should be load all day long. And so this growing from 0 to 200 nodes feels really slow in the context of waiting for a demo, but you know, actually that's quite fast in like the production sense of things. And so if anything, we'll probably sort of slow down the rate at which nodes join. Although I have to put a caveat on that, in that the larger the network is, the more nodes you can join in at any given cycle. There's basically, it has a lot to do with the like internal math of how the sharding is built. And, you know, as we can share more and more technology with our community, you know, I think people will be excited to learn about that. But basically at these lower network sizes, like, I mean, actually 200 nodes is kind of still to us like a small network. The nodes have to kind of trickle in, and then as you're building up, you know, 1,000 nodes, 10,000 nodes, 20,000 nodes, you know, at any given time, you can add quite a few nodes in a network, and it's perfectly fine. And that really has to do with the,
So it'll kind of be like an exponential growth, huh?
Exactly. It's an exponential growth.
And that's because the nodes can, when you have a lot of active nodes, there's more nodes available for a new node to sync from.
Yeah, there's more to sync from, and then also sort of the let's see,
The number of syncing nodes that can be supported is sort of like a percentage of the active nodes.
Exactly. And it has a lot to do with who's holding the state as well. So, you know, if there's 100 nodes and that's the full network size, they hold 100% of the state. So if you were to just try to, you know, add 200 more nodes, you know, if you did that in one cycle, which is like, you know, a 60-second time window, you know, that would be, you know, sharing all the state of everything, like, you know, this huge amount, and it wouldn't really it wouldn't be the right way to do things. So
Andrew, do you have the chart open on this one?
Yeah, I've got the sync timeline here, and
Okay.
what this shows is kind of every cycle it shows nodes coming in, and basically the way things are tuned right now, it'll sync a few more nodes in. Occasionally there's a cycle where there's not nodes syncing in, but we have a lot of settings to adjust this. Right now it's kind of aligned, but then as the network grows, it just kind of becomes an exponential curve. I actually still have the screenshot of the one we did it, you know, late last night at our second or third, you know, demo run, where we grew the network initially, and that was 100 nodes. We took our time running tests and whatnot, and loading the network down, and then we added 100 more nodes, and they were growing here. So that second batch of 100 nodes grows at a steeper rate. It still takes about 20 cycles there, but it does grow faster. And then, you know, growing to 500 nodes or 1,000 nodes, it starts to add them on even more per cycle.
How long do you think we have before we get to the 200 nodes getting in?
All right, we're at 116, so we're probably
About
like 18 minutes away.
Okay,
Yeah.
cool. So we have more time for questions.
Yeah.
Yeah, and I also just wanted to maybe take some of this time to explain just, you know, what we're looking at here and some of the deep technical topics, and making those simple and easy for maybe people who don't have the level of education that some of the team members here have. So, you know, one thing I wanted to discuss is, you know, Omar, we've talked today a lot about, you know, dynamic state sharding, and that's what we're viewing here in this network is a, you know, a state sharded network. Could you just, you know, in simple terms, you know, define what that is and the value it provides?
Yeah, definitely. So, you know, a lot of times people just talk about like state sharding, and they don't differentiate between static state sharding and dynamic state sharding. And you know, everybody basically is kind of assumed that with state sharding, you can take the address space and, you know, divide it up into different shards, and then allocate a different group of nodes to each one of those shards. And that works out really good when your, you know, blockchain is actually, you know, processing all the transactions on a per, you know, block level. One of the innovations with Shardist, and I've mentioned this in some of my previous talks as well, is that we are processing each transaction individually, in the sense that, you know, there's a separate consensus done for each transaction rather than grouping them all together into a block. And this helps us avoid the, you know, problems that you run into with atomic processing of transactions when you group a transaction into a block, but, you know, maybe it gets into a block on one shard, but doesn't get into a block on another shard. And then now you have to, you know, deal with a lot of complexities to prevent those kind of problems. So with Shardist,
I was just going to say, I think one of the challenges in communicating with you is you're so intelligent that you know, you bringing down your level of communication is still higher than, you know, people like me when I'm trying to you know, understand some of the deep tech here. So, you know, I think one thing you talk a lot about is the scalability bottlenecks that blockchains face. You know, you do a really good job of describing like the compute IO, the disk IO, and the network IO. Could you just describe first off, what does IO mean? And then how does that correlate with the disk, the network, and the CPU?
Yeah, so IO just stands for input output. And so typically there's, you know, three main bottlenecks that a computer will come across. You know, one is like the network IO, you know, getting data in and out of that computer, and other, you know, sending that data to other computers. So that's the network IO. So in the case of, like, say, a peer-to-peer network, you know, if you have a situation where every transaction is being gossiped to every other, you know, node in the network, then adding more nodes to the network doesn't help. Every node is still going to have to see every transaction. And so eventually the network IO will become a bottleneck, right? In terms of how many transactions per second this network can process. So you have to alleviate that. The other is the disk IO, where, you know, the amount of data that you can write or read from a disk is limited. And so if every node has to change the state of every account, you know, if it's processing every transaction and updating the accounts that are affected by those transactions, it's going to have to do a disk IO for every transaction. And so, you know, that also is going to limit your scalability. And then the third is your compute bottleneck. And it's not really so much of an IO bottleneck, but it's just, you know, there's a limit on how much computing power you can have in a node, right? And so, of course, you know, nowadays we use lots of cores and hyperthreading and so forth to push that up. But still, I mean, you have to design your software in order to make use of all of these, you know, different cores. And, you know, you have to kind of design your software to run in parallel. So that adds, some complexity to how you design the software. But also, if every node is having to validate every single transaction, you're eventually going to have to keep boosting the number of cores in your computer and try to vertically scale as the TPS goes up. So,
And then
these are the
network
kind of
becomes-
bottlenecks that you'll come
Yeah.
across in an uncharted network.
And then if you have to vertically scale, it becomes more centralized, right? Because the cost of operating hardware to run a node becomes so expensive that only a few institutions are actually, going to be the ones that can afford the hardware, right?
Yeah, absolutely. Yeah.
And so based on the bottlenecks you just described, if a network is not sharded, every network is going to have to send every transaction to every node. Every node is going to have to process every single transaction and then send every transaction to its disk to update the current state of every single address that is involved in a transaction. And so networks need to be sharded to be able to mitigate these scalability bottlenecks. But there are different types of sharding that mitigate different scalability bottlenecks. And you've talked a lot about like iterations and generations of sharding. Just like with the iPhone, when the first iPhone was released, it looks a lot different than what the iPhone we have today, and it has improved in each iteration of the iPhone. I think you said the same goes for sharding. So could you talk a little bit about the generations of sharding and how we got to where we are today with Shardeum?
Sure. Yeah, I mean, first we started off with like no sharding at all, right? So, you have the networks like Bitcoin and the original Ethereum, which had no sharding at all. Then we started, thinking about doing some level of sharding, where I think that Zilliqa was probably the first one where they just did compute sharding. So that helped in terms of alleviating the amount of compute power that a node needed to have, because the transaction would be validated by different nodes. But they didn't do network or disk sharding, and so that still resulted in those bottlenecks. And so your upper limit on the capacity did increase a bit, but it didn't become something that you can continue to push up by adding more nodes to your network. Ethereum originally started out, thinking that they're going to do state sharding, but then as time went on, they decided to rely more and more on second layer solutions, and now they're just doing data sharding, which is kind of, you can also think of it as the disk IO part is being alleviated a little bit by having multiple shards act like as if they're multiple disks, really. And so it's kind of like having parallel disks rather than just one disk in which you can read and write from. So that helps, but it doesn't really solve the whole problem, because now you still have to send that transaction to all the nodes. It still has to get processed by every node and validated and so forth. So that's kind of like the first generation of sharding.
Yep. So let's just stop. Let's stop there for a second. So if a network isn't sharded, the only way it can scale is vertically scaling, and then it's going to become centralized. In the first generation, sharded networks, we've seen a one-dimensional sharding where they get some speed up boost or some benefit from mitigating one bottleneck, but you have the other two bottlenecks, depending on what bottleneck they chose to mitigate in the form of sharding they chose, that you still have to overcome. And so now, we have static state sharded networks that do mitigate all three bottlenecks, right? But there's then some inefficiencies in static state sharding.
Right, exactly. So, the first generation of sharding, as you mentioned, just got rid of like maybe one of the components, but still the other ones still limit the capacity, and so it's not truly scalable in the sense that adding more nodes will help. So the second generation of sharding, I think we're seeing this with projects like Near and Harmony. What's happening here is that we now actually have state sharding, and state sharding basically means that you take the address space, you divide it up into different shards, and you allocate different sets of nodes to process each of those different shards. Now that architecture can help you eliminate all three of the bottlenecks, the network bottleneck, the disk IO bottleneck, and also the compute bottleneck. But when you have these very static shards, what happens is that everything is great until you want to grow and add another shard. And at that point, now you have to, so you kind of first of all have to wait until you get enough nodes joining the network where you have enough nodes to create another shard. And then once you decide to create another shard, now you have to, think about, well, how do we reallocate this address space, right? Maybe if you had 4 shards before, and each shard was holding 1/4 of the address space, now you add another shard, and now it's going to be holding 1/5 of the address space, and this new shard now has to pick up all the data that some of the other nodes are going to be handing off to it. So there's a huge amount of data transfer that has to happen, and a lot of IO that gets involved whenever you're jumping to add another shard. Also, if you ever decide to shrink the network and remove a shard and merge shards, that also creates a lot of complexities in how that's going to be done. I haven't actually seen the other projects talk about the details of how this is actually going to happen. I think they may still be working on these things. Now with dynamic sharding, what we have is a scenario where we don't have any very static shards. Each node is just covering a subset of the address space, but the only thing that we guarantee is that, hey, if you want a redundancy of 100, then we'll just make sure that for every address, there's 100 nodes that are holding that address, right? So with that kind of an architecture, then every node that joins the network automatically can contribute to increasing the level of sharding in the network, and thereby increasing the TPS. And you also have, you don't have a situation where you suddenly are creating a new shard and there's going to be a whole lot of IO that has to happen between these nodes in order to, reshard the whole network. There's a small amount of, resharding that's going on in the background all the time with our network. And, with that, you don't even notice it really. So, yeah, and
Awesome.
so that's the second generation of sharding is basically the static state sharding. And then I would say the third generation of sharding is what we're doing with Shardeum, which is dynamic state sharding.
Got it. And so, like the second generation static state sharding, mitigates all 3 bottlenecks, but there's still inefficiencies in there that are going to cause challenges as these networks grow and scale over time to, achieve the ultimate end goal of enabling the global adoption of decentralized applications. And so what we've done with dynamic state sharding is build the most advanced form of sharding that mitigates all 3 bottlenecks and delivers an experience where TPS can increase per every node added and be truly linearly scalable, right?
Yep, and good timing. I think the network is all synced, and we've got 200 nodes in the network.
Yep, they are here. So what we'll do is I'm going to start load testers, but twice as many this time. So it'll be twice the load as when we had 100 in the
So how
network.
many is that, Andrew? 12?
That's 12 load testers. There will be 240 smart contracts for ERC20 tokens. And
Got
we'll
it.
have about 1,200 end user accounts just randomly sending tokens to other users. Random, picking from the list of tokens and randomly sending them to each other.
Awesome.
And so those token transfers, those are smart contract calls. So it's, executing the EVM, and
Awesome.
it's a good test. I'm gonna stop my screen share for just 1 second while I double check my deploy commands here. My load test start commands, just so I don't have another user error. All right.
Yeah, typical demo situation.
Yeah. All right.
I think
I am
every demo should have a demo failure or some glitch. So I'm glad there's just a glitch, and we are now at this stage. So yeah, all the best, Andrew.
All right. Thanks.
And so Andrews, did you want to say something? Go ahead.
I was just gonna say, I appreciate that you guys had some, we're able to talk more about the project, and
Yeah.
I'm gonna share my screen again. And the contracts are deploying now, so it'll be like last time where we deploy the contracts, 240 smart contracts.
So
Then,
those little red dots are actually transactions going through now, right?
That's right. And of course, the red dots, they represent where they're injected to a node, but it's not that just that node does the processing. It certainly gossips around and is handled by a transaction group, which is a set that's the consensus group for each account. And when there's multiple accounts, that means multiple consensus groups. It could be that in a smart contract call, like the end user address is over here roping in some nodes, and the smart contract in its state lives over here, and they have to join these. They have to merge these together in a transaction group to provide a consensus.
Do you have the chart going, Andrew?
Yeah. So this chart, what we'll see is kind of like last time. We'll see kind of a small bit of load as we're deploying the contracts, and this is just based around. We use this load tester also has like a bunch of validation options. So when we're developing on a daily basis, we're using this to deploy smart contracts and then call some like exhaustive calls into the network to make sure every node can reply back and validate that it has correct state. And so the pattern for what we have at the moment is that we deploy first and then run a bunch of smart contract calls. But so it kind of waits a minute to let the load testers all be ready to send, and then we will see that load ramp up. And on our node sync timeline, it's I was talking about it exponentially growing. It's not something you see a ton at this small number of nodes, but you can tell how it was starting to curve up a little bit, and this bringing in more nodes per cycle at this stage.
It
here we go. Here's
more noticeable with thousands of nodes.
Yeah, it's very dramatic with thousands of nodes, and in past, let's see, or here we go. So now the transfer transaction load has started.
And our average TPS should start climbing up.
Yeah,
right?
this will go up a little bit more. There we go. So if I go over to charts, we've got, our load is high as expecting. So just like the last test, I'm actually throwing more transactions at the network than than we expect it to handle, but that's also a really good test and a good way to see where the network maxes out. So with 100 nodes, we were maxing out at, kind of on average about 40 TPS, and looks like we're right about where we want to be here. It's gonna go up and down a little bit, but we're gonna be in the 80 TPS range. And that's really great to see because, like a single node right now, we have kind of maybe running around 15 TPS, and or if it was a single shard, that's what we'd be looking at just at the moment. That's not, perfectly final numbers, but then again, like it's been mentioned, we're not trying to super vertical scale or anything, and horizontal scaling is a lot better anyhow. There's only so much vertical scaling you can do when you're starting at sort of 15 TPS with what we've got in these very modest nodes, and we want the validator nodes to be modest nodes, so they're affordable and properly decentralized. But when we can horizontal scale and linear scale like this, we're going to see much higher TPS than we could ever see otherwise.
And the kind of TPS that you can expect from the network really kind of depends on, how a compute intensive a transaction is really. If it's like a coin transfer transaction, like with the native coins, they're lighter weight, so you can actually get higher TPS. With these ERC20 token transfers, they involved, invoking a smart contract, and so they're a little bit more expensive. Now we demonstrated, with Libertas network, we were able to get like approximately 5 TPS for every node that we added to the network, because those are like really lightweight transactions. So yeah, just to keep in mind that the type of transaction will cause your TPS numbers to go up and down a bit too.
Hey, Andrew, the person that's live streaming this still has the Zoom video over the chart. You think you could just move your monitor or your browser over to the left a little bit?
Yeah. Let's see.
Yeah, just
Give me a second.
And so Nischal, we just saw 100 nodes do 40 TPS, and then we saw 200 nodes do 80 TPS. Your mission since you started with ZeroX has always been to onboard India to crypto. What does the ability to increase TPS by just simply adding more nodes mean for your mission to onboard billions of people to crypto?
Yeah, I mean, look, we've already seen, what this does to scalability. Even in Web 2, for example, the reason why, today you're not worried about using a Web 2 application and telling your friends about it and getting everyone on board is because when your friends join, it does not get expensive or difficult for you to use that product. Maybe for a certain period when everyone's trying to scale up, but it's never about scalability. It's all about adoption for everyone. In decentralization, it's at least because we are in the whole initial period, the fear has always been as this network grows, I'll need to pay more. And now when India is onboarding and a lot of other developing nations are onboarding, a lot of us are not first to having gotten into a blockchain. We are now joining existing networks where the transaction costs are not even $1. I've seen $10, $20, $30 per transaction. What that means is, for me, if I'm joining, I'm joining, the whole blockchain ecosystem today, I'm going to probably stay away from this whole decentralization and maybe stick to centralization, because it's just prohibitively expensive for me to join. Now, when you bring in a network where you say that the fee is going to be low and it is going to remain low, and the only thing that we need to do is bring more nodes to join the network, And this just opens up the whole decentralization to everyone, not just people who have the money to spend on high transaction costs. So I think what I'm excited about is that Shardeum going as and when we go live, we're going to bring all of those people who are now on the sidelines because decentralization is expensive. I think the world is sold on the power of decentralization. What they're now waiting is for them to be, able to afford it. So today we know decentralization is amazing, but we also look at it as expensive. Now people might say, okay, there are other chains, some might be, cheaper transaction costs, but I think this is where Omar, one of the things he said was initially everyone who launches can be, cheap and low cost, but they all have a certain threshold. So once you reach that threshold, the same story goes all over again, where the transaction costs will increase, and again you will all look for new alternatives. So this is where I think Shardeum is that solution where you don't have to worry about a upper ceiling. Everyone can come in and the network can grow, and I think I'm the most excited about that. But all said and done, I think it's a journey. And the best thing is we have everyone who's watching this, and we have thousands of people, ideating and working together. So I believe if this large community builds, and the best thing is for a lot of us, this is the first time we're experiencing an amazing L1 project being built out. So I think that's this whole journey is going to be really amazing, from building to launching to all of us getting together and spreading the word about this. I'm super excited, and I think the next step for all of us is to have the Alphanet launch, which is going to be this month. We'll announce a date soon, and then we would love for everyone to launch their projects out here, test out your transactions, send tokens to your friends, all from the faucet you can get it. Let's just play around with this, and I think that will help the tech team discover bugs, problems, whatever that happens, so that we can then really get to work and solve those issues that all of you experience. Because the ultimate goal is we want to make decentralization accessible and affordable, and I think Shardeum is that amazing solution. What you've seen is a very small, I would say, glimpse into what is possible. And thanks a lot to everyone out here. I think the tech team has done a lot, and I'm so glad we could experience and we could see this whole thing. So yeah, I think thanks everyone. Omar, any thoughts? What's the next few weeks look like for all of us?
Yeah, it's going to be like really busy for us guys. As we prepare to actually put this out there for the community to play with, but it's super exciting. I was just mentioning to the team that, years ago, as we were building the Sharding infrastructure software, we had talked about the possibility of a smart contract platform on this, but we just never thought that, we would actually see this day come about, and here we are. And it's just amazing to be able to be building this and bringing this to the world now.
No words.
Amazing.
No words.
Sorry, Greg. Go on.
Yeah, I was just going to say, no words can do justice for what we just saw. 40 transactions per second at 100 nodes to 80 transactions per second at 200 nodes. It's all we're seeing is numbers change on a screen. And there's no words we can do to justify the excitement of what we just saw. But in my eyes, it's like, fireworks exploding in front of me with excitement. Now all we need to do is add nodes to a layer 1 smart contract platform. TPS can scale, fees will remain low forever, and developers can just focus on building amazing decentralized use cases that can be adopted globally. Everyone in this space wants a globally adopted decentralized world. And this technology is what gets us there. We only saw 40 TPS at 100 nodes today and 80 TPS at 200 nodes. But, Omar, what is this going to look like when we get to 1,000 nodes, 10,000 nodes, 100,000 nodes? What are we going to see with the TPS?
Yeah, so I mean, if you look at Ethereum, there's like I think 300,000 nodes ready to join the staking system. I think we could see numbers like that, right? Hundreds of thousands of nodes, and maybe eventually 1 million nodes. And if we can even get like, let's say, a half of a TPS for every node that joins the network, at 1 million node, we have 500,000 transactions per second. I mean, we're now well into the range of what centralized platforms do, right? So even when we get to 500 TPS, we're already more TPS than what we've ever seen on any day across all of the smart contract platforms so far, right? So yeah, so it's going to be amazing. And I think the most important things for developers is being able to say that, hey, I'm going to build on a platform where it's going to guarantee to keep the price, the transaction fees low. I mean, it's one thing to say, we have transaction fees low now, but who can guarantee that they will be low, right? And so we're going to be the first platform that can do that.
Super exciting.
This just
And
came from one of the developers on our Discord channel, that this is the building block of all blockchains. You literally made the backbone of divergence. I don't think you realize the application of this magnitude. So Brewmaster, thank you for this comment.
And final question is, we mentioned EIP 2930 today. Today was the first ever implementation of EIP 2930. What is EIP 2930, and what did we do today?
Yeah, so basically, if you have a sharded network, it makes a lot of sense for a transaction to specify upfront what addresses are going to be accessed. So EIP 2930 is a Ethereum improvement proposal that says transactions can include an access list with the transaction, and this then immediately helps the network to route that transaction to the appropriate shards, and you get faster processing with EIP 2930 transactions as opposed to non-EIP 2930 transactions. And this is the first time that I think anybody has actually ever demonstrated a network implementing and showing EIP 2930 transactions being executed. Are you on mute?
Oh, yeah, sorry about that. Awesome, amazing stuff to see today, and all thanks to two very high caliber, skilled founders and a very strong team and a fast growing community. I think non-EIP 2930's tokens our transaction is, what's up next for focusing on sharding. Nischal, just to wrap up here, what should we invite the community to do moving forward? And I also don't think we've announced the Alphanet launch date.
Yeah, so we'll soon announce the launch date, and I think as soon as we launch, the most important thing for all of us is to test it out, try it out, get our friends to try it out, and if you're using apps already, you can just start using them on the Shardeum testnet as well. So I think it's all about educating everyone about what Shardeum is, and sessions like these, we're also attempting the same, which is to explain to you what we're building, and not have it as a black box, but really open up about everything that is being built, so that you can move that knowledge over to your friends and people around you. Eventually, this is how we grow the whole decentralized ecosystem, which is talk about things, talk about the innovation, and get people to experience it. So look forward to all of us, pushing for this Alphanet into the hands of as many people as possible, and we'll announce the date soon. Probably this week, maybe we'll announce the date. I think the only reason we are waiting is for the foundation to complete, and as soon as we have that completed, we'll announce the launch date for the Alphanet.
Amazing. Well, Thanks, thanks everyone for the demonstration today. And Nischal, just to recap, I think a lot of people are looking to achieve success in their life, and you've done it twice with Crowdfire and also with WazirX. And I think for someone just starting out today who hasn't built a business or achieved the success they want to achieve yet in life, this is a great opportunity to get involved at the Shardeum, community at day one with the most advanced smart contract platform introduced today, and start building applications on Shardeum. If you're not a tech person, find a tech person who you can, work on a decentralized application idea with. You can build a blog and become a leading media outlet in the Shardeum community, which one day will probably have millions of monthly website visitors per month. There's so many opportunities to take advantage of this and achieve success just like Nischal and Omar have in their life. So I just wanted to get that out there. But
yeah, no, I think it's a very crucial point, and we're all here. We're all here to help anyone who's building on Shardeum. Please feel free. Do join the Discord. I think Discord is going to be one of the best places to collaborate, and this is the best time to get involved, I think. Oh, we've completed 5,000 members on Discord, by the way. Good end to the session. All right. Thanks, everyone. I think we'll see you guys soon with another demo as we improve. Like I said, I think we'll keep having these sessions and have you go through what we work on and what we are going to launch. Before the launches, we'll always make sure we have this kind of a session with everyone. Thank you so much. Thanks, Omar. Thanks, Greg. Thanks, everyone else. See you. Bye.
Bye.
Bye.